What's happening on this fine Tuesday, guys? Welcome into our math class in Algebra 1 for the day. I did forget to mention in last class period, I hope you saw the note that I put on Facebook whenever I made the post on our class page, that our homework, which is quiz 3, all right, quiz number 3, that it was assigned yesterday. And the good news is you're actually going to end up with an extra day to work on that anyway. So if you haven't started, you're still really going to have, I'll give you 2 class periods from the day before that needs to be turned in. So with it being Tuesday today, please make sure that that's turned in to me by Thursday, and that's still just fine for the weekend. We have a pretty easy, I think, math lesson today. Yesterday wasn't really that hard, I don't think, but it took some time to go through it. I don't believe it's going to take quite as much time. And what we're going to be talking about in our class period today is multiplying radical expressions. Now you might hear and see that and say, wait a minute, didn't we already do that earlier in the chapter? Yeah, kind of, but we didn't FOIL using those. And so we're going to FOIL in multiplying radical expressions. So there's going to be more multipliers, and then we're going to combine the thought of adding and subtracting like terms and breaking down squares further and into its prime numbers and things like that. So let's get right to it, and we're going to do number 1. Again, I don't think it'll take us nearly as long as our lesson took yesterday. I hope that's the case. That'd be wonderful. If so, to give you guys just a little bit of a mental break. Number 1, multiplying radical expressions. Guys, all I'm going to be doing is FOILing. I'm going to multiply this times this, this times this. Try to stay out of your way here. This times this, that times that. I'm not going to draw those lines because our space is so limited, and I don't want to make it any more jumbled than what it already gets anyway. So I have the square root of 7 plus the square root of 2 in parentheses times the square root of 3 and then just minus 6. So let's start with our first one. What's the square root of 3? Okay, square root of 3 as we're used to saying it, times the square root of 7. Square root of 7 times the square root of 3. What is that? That is square root 21. Square root 21. What is the square root of 7 times negative 6? Now don't get confused by this. This one doesn't have a square root symbol, and therefore it stays outside as its own entity, negative 6, but it's going to be times or multiplied to the square root of 7. So does that make sense? Square root of 7 times the square root of 3, they're both square roots, so you just combine those multiples under one square root symbol, square root of 21. However, the square root of 7 times a whole number, negative 6, the negative 6 stays on the outside, and the square root of 7 stays by itself underneath because one has a square root symbol and one does not. Now let's move on to the second term in the binomial. The first one, that is. The square root of 2 times the square root of 3 is square root what? 6, but it's going to be plus, keep your sign, plus the square root of 6. And then we're going to have the square root of 2 times negative 6, which again, the whole number stays on the outside because it doesn't have a square root symbol. And that square root of 2 stays all by itself on the inside. And guys, I cannot break this down any further because there's no perfect square. It's a factor of 21 that I can pull to the outside. That's a prime number under that square root symbol, 7. 6 isn't a perfect square. However, like 21, it has no factor that is a perfect square of itself. And so this is, guys, simplified form of FOILing out the 2 binomials that were given in the beginning. We're already done with that one. Let's move on to number 2. And as you can probably guess, it's going to be the only one that's that way. Okay, don't get comfortable to them all being that way. What we have here at number 2, the square root of 5 minus 7 in parentheses times in parentheses the square root of 5 plus 7. Notice those are conjugates. Those are conjugates. And what conjugates tell you is, as a solution, the difference of a square. Now, if we want, we could take the shortcut to this. Okay, we could take the shortcut, and let's go ahead and do that here really quickly, and then I'll show you the longer way of doing it as a reminder. Now, when you have conjugates, meaning they're the exact same terms as binomials, but one's a negative and one's a positive, then that tells you it's the difference of square as an answer, and all you have to do is square the first term, okay? Take the first term times itself, in other words. What is the square root of 5 times the square root of 5? That's the square root of 25. Okay, and it's the difference of a square, remember? And then you take the second term, and it doesn't matter which one because you're going to square it, and whether it's negative or positive, it doesn't matter because you're going to have a difference, a minus of a square. And what is 7 squared? The second term. Square it. What's 7 times 7? 49. Okay. What's the square root of 25? 5. And what is 5 minus 49? The difference between those two numbers, different signs, is 44. And the larger of the two is what? A negative. And so my answer is negative 44. Okay, that's applying the rule, the difference of a square, or the conjugates. Now let me show you. Remember, that's the shortcut. We can go about it the long way, and we can multiply. What's the square root of 5 times the square root of 5? Square root 25. Then we have the square root of 5 plus or times positive 7, which is going to be plus, as I mentioned, keep your sign, 7 square root 5. One has a square root symbol, one does not, so you can't just throw them both under a square root symbol. You only do that if they both have square root symbols. Now we move on to the second term of the binomial, negative 7. Negative 7 times the square root of 5 is simply minus 7 square root of 5. You can't combine those underneath because one is not. And then you have negative 7 times 7, which is minus 49. Okay, look at these two terms since we're simplifying. Plus 7 square root of 5 minus 7 square root of 5 just cancels itself out. That's 0. And that with which I'm left is the square root of 25, which is 5 minus 49. The difference between the two is 49 minus 5 is 44. And since the larger number is a negative, I retain my negative sign. So you see, if I FOIL it all out, I end up with the same answer, negative 44. But if I can just look at it and notice, wait, those are conjugates, meaning they're the exact same binomial expression, except in the middle the sign is different. And when I see conjugates, that means my answer is the difference of a square. I just square the first term, just square the second term, and then throw a minus sign in the middle and simplify from there. Or if that's too confusing, that's why I showed you both ways throughout, or if you're not confident in your answer, we'll just do it the old-fashioned way. And you're still going to come up with the right answer as long as your math is correct. Number 3, the binomial in parentheses, square root of 3 minus the square root of 2, close parentheses, squared. Guys, look. Do you notice anything about that? What you might notice about that is that is a perfect square. Okay? It is a perfect square. And you recall the shortcut whenever you have a perfect square. All that you have to do is square the first term. Okay? Square the first term, which would make it square root of 3 times the square root of 3, which is square root 9. Okay? Now we're going to have a middle term, and because there's a minus sign in this perfect square in the middle term is going to be a negative. And what that middle term is 2 times a and b, or both numbers, multiplied together. Okay? 2 times a and b. which is 3, the square root of 3 times the square root of 2, and what's that? Square root of 3 times the square root of 2 is the square root of 6, okay? And then for your last term, all you do is square b. What is, and that's going to be a positive by the way, what is square root of 2 times the square root of 2? That's the square root of 4. Alright, from here I'm going to simplify. The square root of 9 is 3. I'm going to retain minus 2 square root 6. You can't break that down anymore. And then I have plus the square root of 4. What's the square root of 4? What times itself gets you to 4? Number dos. And so what I'm going to have as my solution, I need to combine these two together. A positive 3 plus 2 is a positive 5. And then minus 2 square root 6. And so that's going to be my solution to number 3. Now, let me show you one more time. And if I'm erasing those too quickly, remember this is a video, so you can just back it up in the recording and write that down or pause the screen. That's the shortcut. Now listen guys, if that's too confusing and you can't remember, whenever you have a perfect square with a minus sign in the middle, I square the first term. For my middle term, it's going to be a sign just like is between these two binomials, and it's a negative, and it's 2 times these two numbers multiplied together. And then for my last term, it's going to be plus this number squared, b squared. And if you can't remember that shortcut, or even if it's looking at your notes, which I know it's in your notes, you've taken them, and you guys are very good by the way at that. Excellent. Compliment you on that. But if you just don't feel comfortable doing it, guys, just do it the old-fashioned way. It's okay. It works out just as well. The square root of 3 minus the square root of 2 squared. You can write that out. Square root 3 minus square root 2 times, in other parentheses, square root 3 minus square root 2. I know I kind of ran out of space right there, but square root 3 minus square root 2, just like what we have right here. And I'll write our products right over here. What's the square root of 3 times the square root of 3? We're just going to FOIL. That's square root 9. Square root of 3 times the negative square root of 2 is going to be minus square root 6. Alright? And then I'm going to have the negative square root of 2 times the positive square root of 3, which is going to be minus square root 6. And then I'm going, let's see, that's the one I just did, isn't it? I'm not drawing lines, so it makes it a little tougher. So my last one's going to be the negative square root of 2 times the negative square root of 2. The negative times the negative is going to make a positive, so it'll be plus square root of 2 times square root of 2 is the square root of 4. So let's combine some like terms here. Square root of 9 is 3. Square root of 4 is plus 2. And what do I do with these two? I have a negative sign in front of that one and a negative sign in front of that one. Do you recall, just like if you're dealing with parentheses, the square roots are very similar in that regard. If you have a negative sign and then right after that you have a square root symbol, what number is always implied to be there, but it's so simple, it's just understood and you don't write it. Just like between a negative sign and the opening of a parentheses, between the negative sign and the start of a square root, there's a number understood right here, and that's the number 1. So it's negative 1 times square root of 6, negative 1 times the square root of 6. And remember, when you're adding and subtracting terms with like bases, which we have, they both have the same basis, square root of 6. What's negative 1? You just do the coefficients, the numbers in front. What's negative 1 minus 1? And that's not 0, that would be 1 minus 1. Negative 1 minus 1 is negative dos. Negative 2. Keep in the combining and addition and subtraction, keep your base Negative 2 times the square root of 6. And so look, what's 3 plus 2? Those are like terms, and 3 plus 2 is 5. Then what do I have left? Minus 2 square root of 6. And guys, check your first answer. Whenever we did the shortcut, it's exactly the same answer. And so you can go about it the old-fashioned way, and you'll still come up with the right answer. Don't kick yourself if you don't recall or if you don't feel confident enough to use the shortcuts. But I show you the shortcuts first because I encourage you, use the shortcuts if you can. It's going to save you a whole lot in the end. Okay, on this one, number 4, what about when you have 3 sets of binomials and you're multiplying those all to one another? Well, the exciting thing is this. Look at these two. Square root of 3 minus 2 times the square root of 3 plus 2. What do you notice? Just like that, shortcut rule. That first set of binomials, these two right here, they are conjugates. And conjugates tell you the rule that you need to employ is the opposite of, the difference of squared. Kind of the same thing, but the difference of squared if you have conjugates. And so for this one, I'm just going to take the shortcut, okay? And if you want to remember what that is, just look back at what we did right here. All that you do for this first set, it doesn't involve the last one, but it's going to help speed things up and simplify the process for us. But what we have right here is we just square the first term in conjugates, okay? And so we're going to end up with the square root of 9, because the square root of 3 times itself, square root of 3 is square root of 9. And then you look at the second term, and because conjugates are the difference of square, you're going to have it just like this, minus, okay? So, what is 2 squared? What is 2 squared? 2 squared, of course, is 4. All right? Now let's go ahead and just maybe simplify that even further. What do you think about that? I think that would be very simple to do so. Let's make, okay, and let me write it down here so I don't make it confusing. What's the square root of 9? 3. Okay, minus 4. What is 3 minus 4? Guys, that is negative 1. Okay? I've already taken care of these first two just in a shortcut rule. When I see conjugates, meaning they're the same binomial terms, but the only difference is the sign in the middle, all I do in parentheses is square the first term, square the second term, and when I have just numbers like I have here, no variables, this is even easier than what we were doing in the past. I just simplify and it whittles down to negative 1. And now what I have left though is negative 1, this simplified, these two, still needs to be multiplied and 2 distributed to this third set of binomials, which is the square root of 6 and then minus 4. So what's negative 1 times the square root of 6? Negative 1 times the square root of 6 is negative square root 6. The 1 is there, we just don't write it. It's understood. What is negative 1 times negative 4? That's pretty simple. That is a positive 4. And so my final answer to number 4 is 4 minus 6, or you could write it the way that we have right here, negative 6 plus a positive 4. And either way, it works just fine. How do you guys like that for an abbreviated math lesson? I feel like after yesterday you deserve it. So that's all we're going to do for today. Tomorrow we're going to be dividing radical expressions. So it's a lot like what we've done right up here, and multiplication, division, not a lot of difference between the two and the concepts. And so guys, we will tackle that tomorrow. Enjoy the rest of your math time with some free time, by which I mean take some extra moments since you have it today and work on your quiz that was assigned yesterday, and hopefully go ahead and get through with that. I hope, and I don't think it'll take you too terribly long, and so then you can just be fresh to have a day or two with no homework, and then over the weekend you can work on and finish up what it is we'll talk about the next 2 class periods. All right, guys, have fun.